So basically what we are discussing now, we'll discuss today is deletion
Yeah.
of a node in linked list. See, whenever we want to whenever we have a data structure, right, we need to insert it, we need to search an element, and we need to delete. Like these are the basic CRUD operations. So we need to implement and we need to know how in our data structure, how it will be done and how efficient it is. Because that is the comparison matrix, right? That's why we can
Yeah.
compare, okay, array we have to delete. In array, we know that if you want to delete the last element, it's O of one only. But if you want to delete any middle element, you need to traverse till that position and then delete it. So basically, it's O of n. So in general, if I say the deletion operation in a vector or an array, it's take O of n time. Okay, that's how we need to compare things. Okay, how linked list is better or not. It's also similar, but let's see how we will do that. Deletion of a node in linked list. Okay,
Yep.
so basically, what we have to do. Let's say we have given a linked list. This is a linked list, null, and now, firstly, take up a easy question. We need to just delete the last node of the linked list. Okay. So basically, how we have to do it? Firstly, we start from start node, and then this, and this, and then we need to return like this, and this, and this. We need to return like this. And how will we do that? Let's try to understand it. Okay.
Yep.
So means what we have to do? We have to reach somehow. Somehow there is two methods. Either you reach the second last node, you reach the second last node, and
Yep.
its next is our this node, last node, and we need to just delete it and make this pointer to null. Like either you can do like this directly, reach second last node and make it null. That
Okay.
will do it. That would suffice it. But if you try to understand what happens if I do only this much, I will have this thing and I have the last node pointing to null as well. Basically, I have two separate linked lists. One this and this. I have not deleted it. This is maybe I have pointers, I have pointed to my linked list. This is correct. But in memory, still it is not deleted. Memory,
Okay. Okay.
the last node is still there. Node is still there. So how to fix it and how to do that? So basically, what we have to do, we have to specifically like the delete keyword and delete the
Yep.
specific node to delete this node. So that's why the memory allocated because we have dynamically allocated the memory. It's not a stack memory. I already told you. The stack memory if you allocate, right? The computer or compiler automatically delete it whenever we go out of the scope of the program. But if we have allocated the memory dynamically, we need to explicitly delete the memory. So that's why we have to do it. We have to delete whatever memory we have allocated to new keyword, new node keyword. We need to delete using this delete keyword. We have to do. So yeah, this is the major idea what we have to do. So yeah, let's try to go in the code space and try to understand how we have to do it.
Okay.
So this is let me just copy this also. Be helpful. Yeah, team. dot TPP. Right. So basically, what we have to do, okay, we have already created a linked list. We have created some functions. If you remember, like node, we need data next, and then we have just initialize a constructor to provide the data in the next as null. Then we have printed the linked list. We have got the logic. Whenever temp is not null, we will keep iterating and we will keep pushing temp to the next, and then that's how we're printing the linked list and getting the
Okay.
last node just as minor change in the printing function. Just temp dot either instead of doing temp is not equals to null, you will do temp dot next is not equals to null, so that we reach the last node. So temp holds the last node's value. So basically, that's how we return the last node. And then the crucial part and the main important thing which we discussed in the last class was the add node function to add a node in the linked list at the end, not at any specific position at the end. So basically, what we have to do, just get the last node from the last node function. And then we created a new node basically from the given data. And then we just made the pointers last dot next is equals to new node. So that's how we added a node in our linked list. And this is how like a simple question we have discussed, like number of nodes in the linked list, count nodes. That's how basic operations are there. Let's try to write the delete operation. So basically we have to do we don't need to return anything. Basically void delete, not delete, I should write delete node because delete is already reserved keyword. So delete node. So from last also I should specify from
Mm-hmm.
last. So let's say I don't need to pass a parameter also because we already know we have to delete from the last only. So that's right. Now see, whenever you are performing any operation with linked list, like it's very important to check everything. Like parameter, I am deleting, I'm assuming there at least one node is there.
Yeah.
So whenever you are deleting or inserting anything, inserting you don't need to, but at least when you're deleting, you need to check whether the linked list is empty or not. So how would you check the linked list is empty or not? Tell me.
And would we just ask for size, or would we just do the
There
head? I think
there is no size information in head.
for linked list, right?
Yeah, yeah.
Then at that point, we can just look at if there's a head or not. No, because
Yeah, head
there
is
may
null
be
or
any.
not. Yes, great.
Yeah.
Basically, you will just check if head is equals to null. That means our linked list is empty. There's nothing
Okay.
is
Okay.
there. So you have to do like return. Basically, just say linked list is empty. Linked list is empty.
Okay.
Okay, if it's not, we will go forward. Oh, that's great. Hmm. Then let's try to understand. Now, what we have to do? We have to reach either the second last node and do that. So basically, what I will do is I will do the same thing here. I will use the same concept similar to last node, but just observe. I will also maintain. See, I want to get the second last node. Okay, so
Yep.
I will maintain a prev node. Prev initially initialize with null. Basically, what it's doing is, let me just tell you. Let me just write the code and then I will explain it. Basically, while temp not equals to null, so temp dot next is not equals to null. It's not equals to null. Okay. So basically what I'm doing is temp is equals to temp dot next. Okay. And then,
Yep.
oh, temp we have not initialized. Let me initialize temp also. Node star temp is equals to, uh, node star temp is equals to head. Okay. And now what I'm doing is prev is equals to temp. Okay. And yeah. Now let's try to understand what is happening. See, whenever I am returning, like whenever this while loop ends, what happens? Let's try to understand. See, temp, we already know, we have already discussed that temp will hold
Yep.
the last node. Now, see what I'm doing. Prev, I'm holding the temp's value, means previous will hold like the temps, temps just previous value. See what I'm happening. Firstly, I'm assigning temp to uh, the previous. I am giving the value temp and then I'm doing temp is equal to temp dot next. That means what happens? Let's try to take a node one, two, three. Okay.
Yep.
So basically, let's try to see what is prev and what is temp. So basically, firstly, what prev was null, temp was one,
Yes.
and then we iterated. Then prev becomes one and temp becomes two,
Yep.
and then basically we prev becomes two, attempts becomes three. I'm now trying to understand. Now we will break off because 3 dot next is null and that we reach our condition. That means here we break off.
No. Okay. Okay.
And now, very important to understand, see here. Prev holds the second last node. It holds the second last
Must know.
Okay, that's what our job was, right? I need to reach here somehow because I
Yep.
need to make it first null and then we have to delete it. So let me just add this as well to notes. Okay, it will help you. So basically, let's just clear off. Yeah. So basically, this is how we are working. So we the prev, that's how logic defines, right? Let's try to think, okay, how to get the what our job was. Our job was to get the second last node. So how to do that? So I have defined this technique I have used, right? To give a previous, and this is very helpful in many questions. So yeah, that's right. You got it right?
Yep.
Okay, that's great. So basically, we have now there are two things left. I need to make firstly. Let's try to delete it. Let's try to get the last node from the previous. Or temp is also previous, so we can directly delete like this. Delete
Yeah, okay. Okay.
equal temp. We delete temp because temp holds the last node. Okay. And now
Yep.
there's one more thing left. I need to do uh prev dot next is equals to what do you think?
Probably next equals to no.
Yeah, that's none
Okay.
because we have now my second last node is my last node. So
Yep.
basically, I just need to make it now. Yeah, let's try to see this in action. We have already have our node. Okay, so yeah, let's try to think and then count nodes. No, I need to call, delete node, delete node from last, and then let's try to print it as well. Okay, so
Okay.
before and after, let's try to print it. Okay, let's try to see. See, so basically before it was 5, 10, 15, 20, and it was now 5, 10, 15. So if I just delete two times, so it will be 5, 10 only.
Yep.
Okay. So that's how we have deleted the function and we've inserted at the last node also. That's great. So one question which we were discussing in the last class, let's try to discuss that and then we will move forward to the assignment. Okay. Okay.
Yep.
Now our question which I discussed in the end of the class was, let me just paste that question code as well. This would delete from last. Mm, 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 okay, great. So basically, okay, let's try to go through what we have discussed in the last class. So basically, what we want to do, we want to do, let's say it was a 1 over there, it's a 2 over there, it's a 3 over there, and it's a 4 over there.
Yep.
I want to insert a node at, let's say, two, two positions from the start. I want to do like this, 1, 2, let's say 5, let's say 3, and let's say 4. It's quite be slightly hard, so I I will try to give you teach you try 2 3 times. It's okay if you don't get it in first go. Let's try to focus what we are I'm trying to say. Okay.
Okay.
Okay. So basically we need to do like this. Okay. Now firstly, how would I do? So means I need to firstly reach here. That's my
Yep.
goal.
We will go to the next.
Yeah. Then I will store this node because I don't want to lose it. So I will
Yep.
store it somewhere. Now, the next job is just to connect this to our new node. I connect it to our new node. And and then our new node next will be this, like this. So
Yep.
basically what I'm doing is firstly, let's suppose I temp holds 2. Let us assume I somehow reaches temp 2. Okay. Now what I need to do? Firstly, let's try to store. Node star, let's say store only, we name the variable store is equals to temp dot next. What
Okay.
store is holding? Store is holding 3. It's 3 value, okay?
Yep.
Now what I need to do, temp dot next. Let's create the new node also. Firstly, let's create the new node as well. So if I create a new node, node star, new node is equals to new node. What is the value? 5. Let's create it with the
Yep.
value 5. Okay. Okay, I created a new node. Now I what I need to do, temp dot next is equals
Okay.
to new node.
Yep.
Now till where we have reached? We have reached till here. So basically we have reached till here. 2 connected to 5. Now we have broken this link. So basically this is like this. Now our linked list look like this. Okay.
Okay.
Now
Yep.
I need to now what I need to do? I just need to do uh new node. Now new node dot next is equals to our whatever we have stored previously stored, because we need to connect this it right now. I added this link. That's all. This is the code.
Okay.
This is the important step, 4 step of code. But yeah, we need to understand. If you understand this, it's very easy. But we have to understand, okay, I read somehow to when I have stored this. Why I have stored this? This is very important. Because if I not stored this, right? Because I have changed this. Now they broken into two linked lists. I have don't know the address of three. How will I know that? So basically, to before breaking this link, to say three, then we have stored three's address somewhere, so that when I want to connect this next, I need to know the address. That's why I need kept in the store thing. So that is the important chunk part. So yeah, we have done that. Let's try to see in the code. Okay.
Yep.
So we have the linked list. Okay, let's don't need not to delete that. We will edit it later. So what I'm doing is okay. So basically we have the linked list like this: 5, 10, 15, 20. Let's try to add maybe. mm 12 in between. So it should look like 5, 10, 12, 15, 20. Okay. Two positions from the start.
Yep.
So basically, let's try to see how will we do that. Let's try to see. So, do we need to return anything? No. Add node from K position. K positions from start. Okay. So basically, what I need? I need obviously the head of the node.
Yep.
What else I need? The data of the new node. So let's say val. And what else we need? We need K positions. How much we have to go from the start again? So okay, let's try to okay. Now what's our first job? Our first job is to traverse K position from the start. That's our first job. So basically to keep the traversal thing, let's try to initialize a variable I so that we reaches at K position. So we will write a while loop while I is less than K.
Okay.
Okay. And we will do a I plus plus, and we have initialized our temp also. So node star temp is equals to head. Okay. Now we will do temp is equals to temp dot next. Okay. Let's try to see where we have reached. See, in linked list, what happens is we do not sure we need to write equals to or not, k minus one or not. So instead of doing that, let's try to print it where temp is pointing now. It's very easy. So let's try to do data of L. Let's try to see where we have reached. So let's say add node from K position from start. We will have to give a head node. Let's say data we have already set it 12 and from second two positions. So basically we need to do that. Let's try to see where we have reached. If I just print it out, see we have reached 15. So one node extra we have reached. Okay. So I don't want to do that. So instead of change like here k minus 1. If I want to reach k steps, I need to write k minus 1 because temps basically becomes next, right? That's why we
Yep.
just put it, either you do this logic, keep a prep variable, but why you need that? You just need to change a k minus 1. I think that would work, right? Because we have just shifted one back. So yeah, we reach the right position. Then from two position from start. Okay. So okay, that's fine. Now what's our next job was? We have reached the correct position. Let's try to store 15. Our next node, basically node star store is equals to our temp dot next. We have stored somewhere. Now what I need to do? Let's try to create a new node. Node star new node is equals to new node, and let's say 12. Oh no, no, 12. We have given the data. So basically, well, okay. Now what I need to do? I need to connect temp dot next is equals to our new node,
Yep.
and the new node dot next is equals to store. So this is how we have to do it, and I think we're good to go. Let's try to take it. We have okay, giving few to yeah. Let's try to see. I think everything should be fine. Yeah, see. So basically, it will be added 5, 10, 12, 15, 20. Great. So this was the like crucial part. What we have discussed. See, firstly, we have traversed till K position from the start. Okay, where we need to. Time should point to the correct position where we need to reach. Okay. Now I need I store the temp next because I don't want to lost it. Because if I don't do that, I don't my temp next is changing here. So I've broken that link. So I need to store it somewhere. So I've done that. And then we created a new node. And then when we have done temp dot next is equals to new node. Here, what we have discussed, like temp dot next is equals to new node. And then new node dot next is equals to basically store whatever we have done. We have created like that. Okay. So
Okay. Okay.
this is the part, yeah, like this is the one, like these are the basic functions. Now you can like create more functions like that, deleting save node from the back. So this is the basic stuff I want to give you. Okay, okay, how to do that. If you understand these things, then you will
Yep.
be able to understand many things. Okay,
Okay.
okay,
Okay.
so this is the thing. So yeah, now see, we can do this also. If I know the size of the linked list, from this I can add at the last node as well. Suppose I know the size, so I just tell from k position, I give the size of the linked list only. So it will add at the back also. So this is a general function. Like what we wrote here was basically adding the at the last node was specific, but from this function also we can add at the last node, right? If we know the
Yep.
size of the linked list. So this is the thing. Okay. I think we can good to go with the assignment because this is the basics I
Sure. Sure.
want to teach you. So okay, let's see. Hmm. Uh, let's try to understand this trying to say. Okay. So basically I have to write a C stack class, okay, which
Yep.
implement a simplified stack. Okay. You must implement your own linked list to store the element in stack. Okay. Element in a stack are actually stored in a linked list. Okay, that's why we learn linked list. The linked list is declared as a nested class in your C stack class. Okay, basically
Hmm.
like a linked list class, linked list also has a class, right? That's why
Yeah.
they're saying. And then for your C stack class, provide the member functions. C stack a constructor that constructs an empty stack. Okay, basically
Yep.
empty head.
A
Basically in
constructor.
our
Yeah.
case. So basically a empty null head. Basically, I should say
Hmm.
a null head they are saying in case of an English head should be destroyed as null. Okay, that's fine. And then a destructor that destroyed the stack. So basically deleting the head, delete head is empty. A function that return true is that how would you check? We already know that we'll check head is null or not. null to check whether our linked list is empty or not. We will check head is null or not.
Yep.
Okay. Top, a function that returns the top element of the stack. You need to check whether the stack is empty or not before, obviously. See, top function, obviously, when we will check, right? When we have basically some elements in the stack. If we have some elements in stack, they are saying, give me the top function. So basically, what it does is, see, we need to keep a top pointer as well. This time, one extra thing. Why we need that? Because I want, I don't need to traverse it again and again, right? Suppose there's 2, 3, 5, and 7. They are saying maintain a top pointer as well. So whenever
Yeah.
it's an element, please maintain an element. So I just call top, you just give me the top element of that. So basically, okay, that's fine. Size, a function that returns the size of the stack, basically, number of nodes in linked list. Number of nodes. We have already discussed this in linked list. Okay. Push, a push up the go. That is the same thing. We have add a node at the end. Add a node at end. Okay. This we have discussed how we push means like because in stack we know already know that by default what like this is the concept like the stack we added the any data at the end only, so that's how it is. Pop, a
Yep.
function that pops the top of the element, so you need to check whether stack basically pop means deleting the last element, so delete the last element from last node from linked list.
Yep.
Okay, and empty, a function that empties the stack. Empties means we have to traverse and delete each node. Traverse and delete each node. We will see that as well. We will not discuss this, but we will see that as well.
Yeah. Yeah.
So yeah, basically, okay. So this is, I think, yeah. Let's try to discuss and let's try to think how will we do that. Okay. So basically, okay. The top we have stack, we have size, we have push. Okay. Basically, let's try to understand this and then we will write some code as well. So what we need. So basically, we need a class of something known as C stack. C stack we need. Okay. Okay. Let's try to understand. Okay. We need inside that we have to initialize our linked list class node,
Yep.
basically class node, and we that three things now we have. No, not three. Stack point. No, no. We need to define two things only. The top is of parameter of C stack, not our stack. So int data and node star. Next. These are the two things we have defined. Okay, great. This is we have defined. Now, basically, there are we have to define C stack constructor.
Yep.
And then this is how we have to define C stack. And now what we need to define inside that? We need to initialize basically empty head, null head. So basically, let's try to see. We give a node, so node star head. We initialize. And let's say we just initialize it here. So basically, let's try to write head above only. It will be easier because it should be available publicly, right? So
Yep.
let's try to write it like this. Let's try to write like public. We have defined. Wait, what is this? Yeah. So basically, we all things are public here. This is also inside. This is public, and here basically what we have defined head we initially outside like node start head, node start
Yep.
head, and head we are initializing with null we are initializing. So basically this is our head we have initialized. Now what we need to do? Okay, we have initialized our head. What else? Nothing else we need to inside the constructor. That's done. What else we need? We need to destructor basically. So basically destructor is very easy. Nothing we have to do. C stack.
Yep.
So basically just delete the head, nothing else we need to do. So delete the head. So basically that will delete the head. Okay. What else? We need the top thing. Okay. So basically, instead we need a head node, a top node as well. So node star. You can keep two things. Either you can keep the pointer also of the top thing. And
Mm-hmm.
keeping pointer only, we can keep the integer variable as well. Because it's not necessary, right? Like our
Yeah.
string, basically it would be integer only stack. It would contain character as well. So basically, in general, we are initializing node star top in terms of the pointer only. Okay. So
Yes.
we can keep top. Uh, we can actually what we need. Let me just think. See what is the essence that we need the top element of the string. Okay, we can keep integer. Okay, we can keep. Actually, we don't need any next pointer of this, right? So I think it would be fine. So basically, let's try to keep it in top. Okay. Now what else we need? So basically, C stack we is there, and top we have initialized. Now, if someone like I have to write some function top return the top of the element of the stack. Okay. So basically, let's say void. No, not void. We have to give a integer. We have to return. So we just do no. So basically, let's say, what should I name the function? Return top element. Yeah, top element int top element. So basically, it does nothing it do. It just returns
Mm-hmm.
the top. We will write the
Okay.
logic how we'll return the top, but top will contains the thing. But how we will update top, that is important. We I think somewhat discussed previously when we implemented the stack class, but we will review it again how we will do that here as well because there are some changes because there's linked list is there. So how will we manage that? So top already I'm assuming top is containing the top element. So just whenever someone calls it top element function, it will return the top.
Yep. Okay.
Okay. That's fine. Now stack is empty or not before you call this function. So basically is empty. Let's say it should be bool type. Bool is empty. And then we'll check return. Now this understand this something. Head equal to none. What this syntax is saying? See, this is a bool return type. Now I'm checking whether head is equals to null or not. If it is true, return true. Like return this condition only. I just return this condition. So if head
Yep.
is null, it will return true. And if head is not null, then it will return false. So basically,
Okay. Okay.
inherently in one line only, the compiler understand. Okay, this is the concept. So yeah, I need not to write if head is null, then return this, or then return false. We don't need to write that one line statement. So okay, this is done. Then return the size of the thing. So we have discussed. So basically, I think this one is the easy part. Size, just we need to initialize size. See, I'm not passing here head because we already have the head data, okay, in our class. So I don't need to pass everywhere head because head is already a part of our class, okay. So I don't
Yep.
need to pass head again. So size and then basically inside is there and then just same thing node star temp equals to head and then while temp is not equals to null we will just keep traversing we'll keep a count variable and count equals to 0
Yep.
and then count plus plus and then temp equals to temp dot next temp equals to temp next so basically this is and then at the end we will return this is how our size function works okay
Yep.
fine what else we need push now push thing we discussed in the last class okay I won't write the code again just writing that for it push and we just need the data of that in data
Mm-hmm.
Whatever you want to give me new, just give me the data of that, and I will just write that code. We already discussed this code. So yeah, uh, just we need to push, nothing else we need to return. So okay, we will push it. And what else? Pop. So basically, pop we discussed today only. Void. Or not void. Basically, sometimes in pop operation, they want us to return the top element, whatever we have deleted. Yeah, we need to check. Okay, okay, okay. They are not saying, but sometimes what happens in the pop operation, like what element you have deleted, right? They tell, please return me that element as well. So you can do that as well. Both operation we can do, but I for simplicity, I'm not doing that thing. Or nothing we need to input. There's no input. And yeah. Mm. So yeah, this is a pop function, and it will delete the last element. You can return the last element. What element you have deleted? You cannot do that also. It's fine. It's very easy. We'll do that in code. I will do that.
Okay, sure,
Uh,
sure.
and obviously, we already discussed. We need to check before deleting an element whether the our stack is empty or not. So,
Okay, okay.
and we have already defined that function. So this function we will use here. And then pop is the stack is empty or not before you call the function. You already empty. This is interesting. This new thing. Okay. So basically, what we will do. Okay, let me start new page. So make empty. Let's say void is only the thing. Not we are not returning anything. This one more function we need to implement. Make empty. What it need to do is see. Basically, what we have is our node is like 1, 2, 3, and 4 and null. Suppose I just deleted my head node. What will happen? I will lose my linked list. If I deleted my head node, my linked list will in the memory will look like this.
Okay.
I have lost my control of my linked list. If you tell me, can you give me the linked list? No, I can't give you because I lost my head. But in the memory, it's still holding the space. So what they are saying is implement the function make empty. So we have to delete explicitly each node. Basically, you need to delete the complete node. Nothing should happen. Should remain. Okay. So we have
Yep.
to traverse and then delete each node. So basically, what we'll do is again node start temp is equals to head. Okay. Then while temp is not equals to null because we need to traverse the complete node. Temp is not equals to null. What we will do? See, now try to understand very important concept. If I do this
Yep.
directly, try to understand what will happen. I can't do this, right? Because
Yeah.
if I deleted it, how will I go to next?
Yeah,
Temp is
exactly.
already temp is already done. So there is minor change we have to do. Instead of doing this, we'll store somewhere node star p is equals to temp, and then we will delete p.
Yep.
Okay, this is important. We'll delete P. We deleted one and then we push temp is equals to temp.next. Yeah, temp is just a variable. We just initialize in temp.next. We deleted P. So yeah, this is how. But actually, you have to do like this. This is very important. This order should be different. Firstly, make it next and then delete
Okay,
because
okay.
temp is already deleted, right? Because firstly, let's try to because if you do this above thing that will give you a error because this is already null. How you're initializing it because you can't access temp, right? Because it's already deleted. So firstly, push to next and then delete it. So this is how we have to do that. So yeah, these are the function I think mostly. Let's try to implement this in our code base. We will see that and then let's try to create hmm, 15 or 2. So let's try to do that. I think we have enough. Yeah, we have time. Yeah, let's try to implement some functions and whatever left, we can discuss it in the next class.
Okay.
Music, TV, okay. Nine, okay. Let's try to understand. Okay, let's try to create the C stack class C stack. mm, okay, so here we initialize the C stack class. Then we made everything public. Public. Okay, now let's try to make the class node class node and class node. Okay, this is our class node, and then basically what we need to do. See, we can initialize this class node outside also explicitly, like we are using it. But they're saying you should use nested. That's why I'm using the nested one. You can
Yeah,
keep this
makes sense.
outside, okay, right? Because linked list is we can use anywhere, okay? But they want why they are using that why they want that will increase the encapsulation part, right? I'm controlling the node from I can access from the cstack class only. Like I can't explicitly call the node class. So that is maybe some security reasons are there. That's why we want to implement it. So that's why.
Yeah, yeah.
So yeah, this is class node, and then same thing in the data. Again, public we need to make it public data in not in star next. Yeah, this is how we initialize our class. Now we need to initialize what the first thing was. Let's try to see. So basically, first thing was initializing the constructor. So basically, let's try to initialize the constructor. Okay, here also we need to initialize the constructor. Node int val this dot data is equals to val val and basically index is equals to uh,
10 or not?
and- yeah, and then our node class is initialized. So yeah, nothing we have to do in the node class. Nothing
Mm-hmm.
is there. Okay. Nothing is there. What happens? Certain identify. What happens? Node value. Oh, here we have to put. So this is done. Now let's try to initialize C stack class constructor as well. C stack. Okay. Nothing is needed. Okay, we need to initialize whatever the data members we need. So basically here basically public we have already initialized the class. And let's try to initialize node star head. Head we initialized. What else we need? Top we need. So top we initialized. Top we initialized. Okay. Top, let's say we say it's to be initialized with -1. So we'll initialize
Okay.
it constructor only. So yeah, top is equals to -1. That means no element is there. If I somehow in terms of X say that if you find top is equals to minus, that means there is nothing, no element is there. And then head is initialized with none. Nothing is there. Okay, that's fine. So basically, this is done. Now C stack we also initialize and then okay, that's great. Now what else we need? Okay, we initialize our constructor. Now the next thing is destructor we need. So let me initialize the destructor as well.
Okay.
So C stack again, C stack, stack. So yeah, so agility head node. Basically, we have deleted the head node. What else? Now, what next? Basically, top element we need to return. So basically, yeah. So in top element, top element, nothing we need to give as a parameter as input, just return the top. So
Okay.
return the top, and then what else? Next is empty. So bool is empty. we need to check is empty or not. Nothing we need to give. Just check return head is equals to null or not. Okay, we have checked. This is fine. And what else? This is done. Now size. Before that, let's try to do the push operation. Okay, let's try to do the push operation. So nothing we need to return. So push. Now let's try to understand this. Push. We have to do it. Okay. Now basically we will give you a data. So basically a val. Okay. Now let's try to create a new node after that. Node is
Yep.
equals to star. New or new node is equal to new node and the val. Now what I need to do? Now let's try to understand. Let's check firstly if our head is null or not. If head is equals to null, that means what? I need to assign the data and the things to head only, right?
Yep.
There are two things. If our linked list is not empty, then we will do the next thing, and next and next and all. Okay, firstly, one more thing. See, you can keep two things to make our life simple. We will what we will do is, we will okay, we can do that. See, okay. See, I got a one more idea. See, if you want to add node at the end, either you do two things. You traverse every time at the end of the node from the head node, or what you can do, keep a pointer at the end of the linked list only. That will be helpful, right? Because
Yep.
we need not to traverse again and again. What we will do is making the tab top only our node star. It will help because it will give the last node data also, and basically the last pointer to the last node as well. So data also we need and pointer also we need. So yeah, it will
Okay.
help here. Just we need to do some changes. Data is equals to, you
Next.
don't need to do that. Anything I can do that. This is here return top dot data. Okay. So basically you return the top data. Yeah. Now head is null. So basically what we need to do, we have to assign head only. Basically. Okay. So
Yep.
head is equals to new node. We have assigned the new node. And one more thing, top also need to assign. Same thing. Because initially the top is pointing to the last node. And now what is our last node? Head only. So
Yep.
basically, yeah, we need to do that. If else what we need to do? We already know that top is pointing to the last node. So what we need to do? Top dot next is equals to, you know, did you get that? Basically, what we have done,
Yes.
top is already, we already know that the top is pointing to the last node. We just need to do top dot next is equals to new node. So yeah, this is
Yep.
how we have pushed it. Okay, I think this is good enough. Yeah, this is done. Now let's try to apply the other thing. What else? Pop operation. Let's try to apply. Okay. That's how I think, right? Because I need to know what I need to implement. This it helps. Okay, I need the last pointer. So why don't go we go this way that we keep the last pointer in hold only. We need not to traverse again and again, and we have reaching the same thing. We can do better because that's our concept, right? We need to reduce the time
Yeah.
complexity. Yeah. So this is push operation, and then we have to do pop operation. Pop. We don't need anything. So what we need to do, we need to delete the last node. We have the last node. So now it's very important. How would we do that? Okay. So see, now pop operation. If we deleted the last node, suppose we deleted the top, then how will we change the top? This is important. Okay. How will we do that? That's a good thing. Okay. So you can't do like this. Okay. So basically you need to traverse, right? See,
Yeah.
top is pointing to the last node. Now, if I just deleted top, but I'm not able to change my top, right? We will delete the last node. But
Mm-hmm.
when I'm accessing the last node second time, we don't have any last node. So we have to traverse this time till the second last node. What we have done in the
Okay. Okay.
previous part. So yeah, this is how we have done that. Yeah, this one delete node from the last. So basically, what we have to do, we have to do the same stuff.
Okay.
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 So yeah, we have to do pop operation. So what we have to do? We have to go head is equals to null. When we have to then link list is empty. We have checked it. Or we can call bool empty is function also. Both are fine. They can call this function as well. Is empty function. Is empty function. Whatever we have initialized is empty function. Link list is empty. Prev null. Temp head. Temp dot next. Delete temp. And then prev dot next is equals to null. Okay. So this is how we deleted the node. Yeah. We have to do that this time because we can't just delete and we need to change our top as well. So what we have to do? See, prev is our become our last node. Basically, we need to change our top. Top is become prev because we need to change our last node. Last node becomes prev and top points to the last element only. Okay, top becomes prev. Let's try to see this. Is it working or not? And then we will wrap off the class, I guess. Yeah.
Sure, sure.
Okay, that's great. Let's try to initialize the thing, the stack, C stack, C stack, C, let's say, this is our initialize our stuff. Then C dot head also we don't need to initialize head, we just need to push let's say 5 and let's say C dot push 10 we do. Okay, let's try to write a function for printing as well. Basically, void print, same function, nothing, no changes. We can just copy paste from here. Nothing we need to change. Print function is same only. Just not start time head. So yeah, let's try to do that. Print function is same. Yeah, let's try to see. So basically we just call the c dot print function. Print
Yep.
function. Hopefully it should work. Maybe not in the
Yeah.
first go. We will try to debug it.
Yeah, that I think I can do on my own
Okay, okay,
most of
okay.
it.
Maybe there's something is there. Is the okay, we'll just check that it's not equals to not and equals to null or not. Let's try to see. We will just debug it in the next slide as well, or like whatever is the
Yeah,
thing. We
sure.
will okay, maybe it's not locating memory something. Okay, there's something bug is there, but yeah, mostly the idea is this thing.
Yeah,
I will,
I see.
okay. So yeah, this is mostly today's class. If you have any doubt, we can ask it. Like we can solve one. We have some time. Let's try to debug only. I think I have 5 minutes more. Let's try to debug it. What is
Yeah, we
happening?
have 5 minutes. Yeah.
So basically what we have done is not taking the input correctly, right? It's not printing
Yep.
anything. Okay, let's try to say it. So we have initialized our head is fine. This data is well is fine. Node is fine. Okay, data is fine. Top dot data is fine. We are pushing. Okay, because push is the operation something is a problem. Head is equals to new node. Okay, top is equals to head is fine. And else top dot next is equals to new node. That is also fine. So this should work. Why it is not working? Okay, head is equals to null. Okay, now okay. So push we have done it, but it's not doing. Push we are doing 5, and then we are printing the head node, right? Temp is equals to head, and temp dot data. Temp equals to temp dot next. Okay, so but it's not doing perfectly. Okay, why it is
Hmm.
not happening? Okay, pop is push we have defined. Okay, in 12 node. Okay, let's try to see what happens here. Out, let's say what you can say top dot data. Let's try to see that top dot data. If we are assigning things correctly, let's try to see that. Okay. Mm, mm. Okay, so there is some problem here. Okay, that's not going the control not reaching here because there's nothing is printing. Okay, let's try to do things above. Let me just comment this out and okay, let's try to do this here. Count new node data.
Mm-hmm.
Okay, let's try to see where that the control is reaching here. Okay, so it's not reaching here as well. Okay, that's interesting. Means there is some bug is there. Okay, C stack we have initialized the constructor. Okay, head we have initialized with null. Okay, and public is fine. Node star next is fine. This dot data is equals to val is fine. This dot data next is null is fine. Okay, this is fine. Okay, this is fine. Node we have initialized. Top we have initialized. We step top dot data. Okay, okay, okay. See. You got the error, right? See, I have done this thing. Top is
Okay.
nothing is there, right? And top is
Yeah.
actually null. And null dot data I am doing.
Okay. Yeah.
So
Makes sense.
you don't need to do that. Yeah, it's not required. So yeah, let's try to. Maybe this was one of the problem. You will check it out. Okay, this it should work. Let's try to remove this thing. I think it should work now. Yeah, let's try to see that. Yeah, it works.
Okay.
So basically 510. Yeah. So basically, yeah, sometimes it happens. The bugs there. We need to tackle that. We need not to scare from the bugs. We'll just check it out. Okay, what happens? Yesterday I had done a small mistake here. I just did the reverse thing. Val is equals to
Mm-hmm.
this dot data. Yeah. When you write the code yourself, right? Even if you know that, like I know the code, but I made mistakes. This is how you
Yeah.
grow.